if you're here, you're interested in learning more about what this crazy thing is that we're calling DevSecOps these days. I am Andrew Krug. I am one of the instructors for Antisyphon, which notably I had just realized I misspelled on this slide, and we'll correct. But I also work as the head of security advocacy at Datadog, work on Datadog security labs, research reports, all the stuff and things. If you want to get a hold of me, the best way is, in fact, email. My Twitter handle is up there. This presentation is notably and has to be kind of full of jargon. So that's kind of the spoilers here, is that we're gonna go through a lot of industry terms, and we really can't talk about DevSecOps without doing that, because as a culture, we have kind of arrived at this very weird place where we've decided that we have to have all of these different capabilities and facilities to do these things. And we've given them names and acronyms that are kind of unfriendly. And so I hope that your takeaways here in this is really that we break this down in a way that you can understand. Notably, not a ton of this is going to be very, very, very specific to the AWS Cloud, only a small portion. And then the rest will just be kind of general guidance on how to navigate what's really going on in the market right now, as far as how companies are adopting some of these practices. I will keep an eye on the Discord chat, by the way, and respond to you as we kind of go through. There's already a question in the Zoom chat, but I'll primarily monitor the Discord. The first one is, can you get into DevSecOps without ever being a developer? And I think the answer is yes, because there's so many different roles in DevSecOps, just like everything. You don't have to be an expert level developer, but if you're not coming from a developer background, you're going to have to learn how to, make some code, do some code, read some code in order to really be effective in this role. And I think you'll kind of see why as we walk through this presentation. So the DevOps movement was kind of the beginning of all of this, right? We can debate when it started, but I like to say that it began in about 2007, where we started to get on this train of the idea that development and operations teams should probably not be that far apart from each other. And then later on, we sort of figured out, due to some corporate incentives, that DevOps wasn't really working always necessarily the way that it should. There was a big gap in the middle, because companies were kind of optimizing for shipping software faster and faster. And that kind of became one of the primary tenets of, like, hey, are you agile enough? Are you DevOps enough? Are you deploying enough times a day, as a metric? And so what that was doing is kind of incentivizing teams to deploy at a breakneck pace that was so high, they were actually skipping a lot of security controls or patch management, or all these things that we all think of as kind of great in security culture. So we kind of had these two movements that were really, really influential in that. And one was the agile software movement, and the other was the DevOps movement. These kind of went hand in hand in many cases because they had a lot of the same values. The primary tenets were speedy delivery. So we deliver software at the value of business. Kind of prior to Agile and DevOps, companies had really been obsessed with, like, the waterfall method, and this idea that as soon as we make a piece of software, it will be absolutely perfect the first time. Of course, today we know that that is pretty much impossible. So small iterations are kind of the way. On the Agile side, heavy emphasis on customer focus, like taking direct feedback from the people or persons who are consuming the service that you are vending. And then tight, small feedback loops, and continuously integrating those things in an automated way were both kind of tenets of these two movements. And what that really means is that we do the smallest release that we can, and then we kind of collect the feedback, either in an automated way, a human way, and then we roll that back up in kind of the next cycle of work. Unfortunately, for security, all this stuff, when it becomes measured, when you start measuring these things, like what agile software development refers to as velocity, which, by the way, is just like the number of lines of code that ship out the door over a period of time. If we want that hockey stick graph to go to the right and that is the thing that you are measured on, of course you're going to ship code. Sometimes that code is going to be high quality secure code. Sometimes that code is going to be insecure code. Sometimes we're going to totally just like sidestep the fact that we haven't bumped a whole bunch of dependencies or patched to the latest version of things. So because engineering teams are measured on what we call velocity, or the number of story points that they closed out in a quarter, a sprint, whatever, that actually stopped being a great way to measure performance, because those teams were introducing very expensive vulnerabilities in the name of just like shipping more and more quickly. And so that sort of started to create some friction in our business. And we're all kind of familiar with this, right? Which is this perception that's all that security does is kind of like slow things down. And really what development teams want to do is they want to get more code in the hands of customers very, very quickly. So you might notice this is there's a tortoise on the left there and a hare on the right. That is not for no reason, which is that, you know, we sort of need to combat this perception. And we've kind of already done this inside of the security community with red teams and blue teams. So we have this movement in a micro fashion inside of our own industry, which is that we call it purple teaming, which is a lot of the same thing that DevSecOps teams are doing, which is blue teams and red teams working together. In the case of DevSecOps, it's really engineering teams working with security teams, or sort of deputizing people inside of operations and development teams to care more about security, to accelerate feedback, and, you know, finally, and most importantly, leverage empathy. So I think one of the big things about the DevOps movement that made it kind of cool is that for the first time from the top down of a company, we were saying, hey, if you're the developer that wrote this and it breaks in the middle of the night at 3 a.m, you are going to be the person that gets woken up in order to fix that. It's no longer going to be a single operation person's problem. And as a former operations person who has been on call for too many years, that was great, right? Because oftentimes in an ops role, the best that you can do if somebody deploys a bad piece of code is you can roll it back. But as soon as you start putting developers or engineers in the shoes of operations folks, they start to kind of understand what that life is like and why we need more controls, potentially need to slow down, do more testing, because they're starting to see that world through the eyes of an operations person. And DevSecOps is no different, which we're just adding the security lens to that. So as an engineer, we're incentivizing people because they are now accountable to take care of those things, to have the same level of empathy that they would for a security operations person or security engineer that's taking care of that issue. And that is one of the core tenets of DevSecOps from a culture perspective. A couple of years back, I had the privilege of working on a maturity model for DevSecOps, and this is one of the many figure 8 diagrams you can kind of see that goes through the various DevSecOps phases. Today, we're not going to focus a lot on the non-technical ones. So planning is not one that we will discuss, but of course that is as important as everything else, and you should have an architecture process, et cetera, et cetera. But what we will focus on is like the development, the building, the testing, the releasing, the deployment, operations, and observing. We only have the 50 minutes left together, and I hope to take questions from you. And again, if you have questions, please do put them in the chat, because it allows me to engage with you in a way that makes the live event more live. But this is kind of like the workflow that we go through, and it kind of gives you a little bit of an idea of the different tactics that we can put in play at every stage of the software development lifecycle, so that you're kind of like baking security into all those pieces. And I think what's cool about this is that it's not a departure from what we consider to be DevOps. So we still have all the same DevOps phases that we always had, but they have a security element that has been added to each of them. And that is the bread and butter, really, of DevSecOps. So we have all these different phases, right? We have plan, develop, build, test, release, operate, and as a fundamental tenant, observe. So get metrics on all the things through all the phases of the software development lifecycle. And that's really cool because you can't really secure what you can't observe, right? So if you have no metrics, if you have no logs, if you have no traces on anything that you're building, it becomes very, very, very hard to understand how that thing operates and also how to secure it. And this sounds really nice and neat and clean. If we were building all greenfield stuff, walked into a startup day one, this would be a really nice progression, right? We'll get an architecture team together. We will make architecture diagrams and we'll fight it out. The engineers will go and write the code. We'll build the code. We'll test the code. We'll have the most perfect test coverage that anybody ever had. We'll release our 1.0. It will be bug-free, security bug-free. We'll run that for a number of years, and then we'll come back and we'll just maintain it. The sad fact of the matter is really that a lot of us are operating more in realities that look a little bit stranger because based on the needs of our business, we don't always have the ability to go through all of these phases every single time that we want to release a feature or patch a bug or add a metric. So we're kind of jumping into each of these phases all the time for the services that we're building. Or if you're at an existing company and you're trying to back yourself into how do I even add some DevOps or some DevSecOps, et cetera, you're asking yourself how and where you should insert that. And I think that is one of the challenges that we run into in this. And also kind of one of the traps is that you think potentially you can't do this because it has so many phases and there's so many things that you have to bolt on at every stage. It's impossible to kind of break down and do this incrementally. So before we talk about kind of solutions, let's just talk about 4 things that I know to be really true about DevSecOps. The first of which is that regardless of how you feel about this, and you might think that it's dogma or semi-religion to practice DevOps or DevSecOps, if we can get away from the terminology, there is a massive benefit to development and security teams working together. So I think we can all agree that that is always really, really true. The second is that culture here is more important than technology. So I think one of the things that I failed to really understand about DevOps when I was disruptive in the places that I worked, and I am a sort of a disruptive hire, by the way, I come into companies and just sort of upend the development process and create a little bit of friction. It's that you can't grassroots things like this. If I could go back in time and change the way I'd approached a lot of these rollouts, it's that you need this top-down buy-in in order to implement any of these strategies. So that has to be at least director of engineering, VP of engineering. Hopefully it's at CTO, CISO level, and those people are working side by side in order to kind of encourage the development of a culture like this. It's very hard to come in as an operations person or a security engineer and all of a sudden say, working backwards, all right, now we're going to put DevSecOps on this. You are going to add these additional, scanners, controls, whatever, and try to back that in from the ground up versus kind of doing a top-down sale to senior leadership. The next is that the wrong technology is actually worse than no technology. And this is a strong opinion that I'm just asserting here, which is that if all you're doing in DevSecOps or DevOps is you're running scanners and you're just aggregating findings and you're burying your teams in things they actually can't act on, you've actually only slowed the organization down. You've created all of this friction for a data set that is not necessarily relevant. So getting lots of comments in the chat here. Agree because cultures have morality, philosophy, policy, and ethics rather than just technology. Also a question here that says, can you focus on how to apply things such as pen testing to the phases of the DevSecOps lifecycle, I will definitely answer that as well later in the presentation. But again, if you bring in the wrong stuff as part of this, or you try to do too much all at once, that's where this entire system starts to fall down. So I like this slide a lot. The letters here, because you can't spell DevSecOps without DevOps. And that's not to say that you can't put a little DevSecOps in your software development lifecycle, but really this has to be built on top of a foundation of DevOps principles in the first place. So whether you're brand new to DevOps and you're like trying to just go all in on DevSecOps, or you're a DevOps shop that's trying to add a security angle, we still have to have the fundamental pillars and tenets of running a DevOps strategy. So we have to ask ourselves, like, let's say we are that greenfield company that doesn't have DevOps, or they don't have DevSecOps, and you're the first hire to walk in the door and you're charged with building out a strategy and ultimately building a team. You're constantly asking yourself, what is the biggest bang for the buck for the dollars and time spent? So like, where do I dive into this to provide a company the most value? And I think that is in the environments that we're all working in, we're constantly asking this question. So what we have to do is we really have to take a maturity approach. And this is how you don't eat the whole, multi-foot long Subway sandwich in one setting, right? Is that we have to kind of chunk this up a bit. And I use Python to kind of express this because I'm a Python programmer. So like, if we think about the beginning, it's like today. So like the day that we decide, hey, we're gonna go in on this strategy and we're gonna start to incrementally break this down. And then 6 months from now, where do we want to be, and what metrics and controls do we want to have implemented? And then I put a joke here between now and Python 4, because like I don't know that Python 4 has a roadmap launch date, but between now and like the next major version of the language that you're developing in, what do you want to have achieved? So between now and then, you should be able to go from beginner to expert relatively easily, as long as you kind of like break this strategy apart. So I think we're all kind of like inundated as well right now as security practitioners with solutions. And this is an infographic that I borrowed from Gartner for this presentation, which just shows all the phases of the DevSecOps lifecycle. They've broken release notably out in the middle there. If you look at the center of that figure 8, now instead of it just being release, they've broken out pre-production and release. So if you were to have unlimited money and just go out and buy every single tool, every single capability that you could, you would have all of these things in each of these categories through that entire software development lifecycle. We all know with small teams, that's really, really, really rough, right? Because each of these things, each of these capabilities on this map is integrating in some way with credentials. It has to plug into your software development pipeline. We have to assess the risk of each of its findings and decide whether or not that should be a blocking finding or just an informational finding that provides some guidance to a team. There's no end to kind of onboarding all of these capabilities. And then, to kind of add more complexity to that, each of these tools or platforms that we onboard is going to output findings in different formats potentially and to a different place. So, I mean, we're literally just like swimming in tools. And I think that is one of the hardest things. And I keep coming back to this presentation that I actually saw Clint Gibler give in 2019 and 2020, which was called How to 10x Your Security. And it was not notably a DevSecOps presentation. If you don't know Clint Gibler by name, he is the author, writer, and founder of the TLDR Sec newsletter. And nearly 4 years ago now, he gave this presentation on how to 10x your security, and it holds true for a lot of DevSecOps work today, which is that what we should really be doing is thinking about how to target vulnerabilities by complexity and class. So in cloud computing and software development, in everything that we do, we have some set of low-hanging fruit. We have some set of stuff that is not so bad to kind of detect and close out. And then we have some set of vulnerabilities that are just like really hard to detect, really hard to close out, but they are also frequently abused. And what we're seeing as an industry in the last 4 years, even since this presentation was delivered, is that our vulnerabilities and the way that they are introduced to our environments are becoming increasingly complex. And that is due to the nature of the way that we build infrastructure. So it used to be, you put a pizza box of compute in a rack, you installed an operating system on it, somebody sat down, they installed some packages, it ran a service, that was its job. Now in cloud, we have all this other stuff. We have the infrastructure as code, kind of side of things. We have the cloud provider side of things. Potentially, you have a containerizer on top of that, like Kubernetes. So it's just increasing the number of things that we need to pay attention to in order to so even do things as basic as assign criticality to a vulnerability. So even though this presentation was 4 years ago, this is effectively what we're all still trying to do. We're still trying to do this basic thing, which is look at the spectrum of things that are vulnerable in the environment, be more effective at triaging them, and be speedier at acting on those findings. However, we are now doing it at cloud scale, which potentially means that you as a customer of these environments have one or more clouds. And I used to say, hey, whether or not you know that you have AWS in your environment, you probably do. Now I'm inclined to say, if you don't think that you have at least 2 clouds, you're not accounting for the fact that you probably have Entra ID or M365 plus your compute environment, which might be in AWS, it might be on GCP. So we have more surface area than ever before. We're trying to do all these things. We're trying to do them at cloud scale. We're trying to do them well, but we're falling down in a number of ways, which is why we continue to see these breaches on these like very, very common sort of issues. So if we were to look at a graph, again, from this Clint presentation from several years ago, this was kind of a vision of the distribution of time that people should spend in different work modalities. So based on vulnerability complexity. So on the left-hand side, we have really easy stuff like, hey, just rotate your certificates, make sure you have strong ciphers, etc. How much time are you spending doing things like bug bounty programs and triage? How much time are you spending pen testing? And how much time are you spending actually monitoring things in production? I think it's interesting all the way on the hard side of this graph. For the hard vulns, that's the first time that runtime monitoring and actually like looking at workloads that are in production kind of comes into this. Because as an industry, we've almost kind of pivoted towards this idea that we need to have as much monitoring and observation at every stage as we are able to in order to make the right decisions. So we're going to break this all down and tie it back to those DevSecOps phases from before. I want to just focus on 4, right? And kind of break down a little bit of the word salad that we are all dealing with on a daily basis. Like if you were to go to the RSA conference upcoming, you would likely see a lot of these acronyms. And to be frank, like these acronyms make me uneasy because the more 4-letter words we have, the more challenging it is for an engineer to know what is the right tool to solve the problem that we have today. So you might notice on the top left here, on the testing side of things, we've now kind of like broken testing down from what used to just formerly be like unit tests and integration tests in a software pipeline now to include pre-production and production. And that is based on the idea that once a vulnerability makes it to production, it is very, very expensive for a company to go and either have that exploited or remediate it in production, because we have to all of a sudden start doing things like walking back releases. So a lot of the workflow that is considered modern application security today, like vulnerability management, SAST, DAST, IAST, RASP, and software composition analysis, or SCA, and I'll break those all down here in a bit. Those have all kind of moved into that testing sort of category. On the operate side, we also have vulnerability management because vulnerabilities are introduced in code. They're also introduced by systems just being kind of like long-lived. I don't know if anybody remembers when we used to optimize for uptime, but as we all know now, uptime is a bad metric because it means that we're not always patching all of the things. So if you have a server system, for example, that's been up for 5 years without a reboot, it probably has never been patched. And in data center days, we used to run a little contest with each other to see how long we could keep different systems alive without rebooting them. Unfortunately, that meant that they would go a very long time without kernel upgrades. We've also introduced things like runtime security, incident response processes. On the releasing side and observing side, we have things like continuous scanning and drift detection, which means, how far away is the production environment from the thing I deployed with infrastructure as code. And then can't stress this enough, all of this is built on a DevOps foundation. So you can't do most of these things if you're not already doing good logs, metrics, and monitoring. Lots of people are asking, what do you recommend as far as a DevSecOps maturity model? Of course, I have the one that I worked on at Datadog, which is incredibly lightweight, very, very easy to do. OWASP has a DevSecOps maturity model as well. It kind of describes and details these various categories more thoroughly. For most folks, I think it's appropriate for you to create your own DevSecOps maturity model for your own company because you will have services and things that map to different phases of that at different points in their life. And we're going to get into that in just a minute here. So again, can't stress this enough. The observe part of this is like non-optional. So the logs, the metrics, the monitoring that underlie all this, that is probably the most critical thing. And then all of these other things are just evolving ecosystems of technology that are supposed to help you triage, remediate, detect different sorts of vulnerabilities in different states in the software development lifecycle. Linux Girl asks, I missed this. What is drift detection? So drift detection is when you deploy something as infrastructure as code, if that is ever touched with human hands, instead of infrastructure as code, it is considered to be drifted from the state that it deployed in, which introduces all kinds of dangerous things. But knowing that something was deployed with IAC and being able to take it to the bank that it is in your desired state is why we do things like drift detection. So the things that are part of a DevSecOps strategy that I consider to be table stakes, like you can't do much more if you don't have these fundamentals in place, are asset inventory, vulnerability management in production, and now pre-production as well, continuous scanning for both code and cloud. So that means I'm going to scan my code for bad stuff, and I'm also going to scan my cloud environment for bad stuff. So let's talk about asset inventory, or as I like to call it, who you going to call? Because really, let's be honest, as security people, we often just want to know who we're going to wake up in the middle of the night. And that is the primary driver for asset inventory. I will triage some of these questions towards the end, but keep them coming. So why asset inventory? Hopefully is pretty clear by now, and that is because modern applications are complex. I may have mentioned earlier in the presentation that I do happen to work at Datadog. I love this service map that is actually in the platform because this is just an example of a really simple shopping cart app and the number of services in a cloud that is required to deliver that app. So if we think about the way that people are building today, they're no longer building on single systems. They're no longer building on monoliths. They're building these microservices, and all of these components represent a single source code repository that is full of attack surface, potential vulnerabilities, needs a governance and lifecycle model for how that team builds and delivers that thing. So That's one of the biggest reasons why we do inventory. The other piece of this is that now not only do we have the inventory for who owns code, and there are a number of standards out there, by the way, for like how to annotate your source control repositories with like who owns that and how to know who to wake up in the middle of the night. But we also have cloud assets that are deployed by that code. So we have servers, we have containers, we have queues and functions and things. And at a minimum, we need to know the owner, the environment, and the service that resource is associated with. So inventory data, if you are collecting it, should be an accelerator for triage and remediation. So if it is not an accelerator for triage and remediation and you're collecting it, I would encourage you to ask, why am I adding that inventory information to what I'm doing? And if you think about it, like through this security lens, when you have a vulnerability that comes in, whether that's a patch problem, a misconfiguration, or a cloud provider vulnerability, all you ever want to know is how impacted am I? You want to know that as quickly as possible. And then you want to know what do you need to change in order to no longer be impacted by that? And then who can change it? So this is kind of like the very, very basic skeleton of what an inventory should be helping you do. So Twilio, actually, notably, is one of the companies out there that does publish the way they do code inventory metadata. They have a great blog that's out there that I've linked in this slide that's called "Can the Real Code Owners Please Stand Up?" And hopefully the audience here is 90s enough that you get that reference. If you want to go check that out, I've linked it in the slide deck here, which has been made available in the resources channel. On the cloud side, a lot of this is powered by what we call tagging, which is just key values that are attached to resources in the environment. If you have an inventory system of any kind, hopefully those tags are stored in a data lake, and hopefully they are also searchable outside of your production account. And that last part is really, really important because when something goes really, really wrong, let's say that you can no longer get access to your production account, or worse, the attacker is smarter than you, or your inventory system is actually running the production account out of describe calls, you can end up in a situation where you actually can't even know what things are running in your account because you get a certain number of describe calls to read the running state of the environment. If you exceed those, you can no longer do that for a certain amount of time. You get exponential back off, etc. There are notably open source solutions out there. This one is a great example of open source innovation at a relatively large company. You may have heard of them, Lyft, rideshare app. They created a service called Cartography, which is a very similar service map to the one that I showed earlier. All it does is show you related assets in a graph database that then you can store and warehouse in another account. It's annotatable with metadata, sort of similar to the commercial solutions available. So pretty cool there. This is an area, though, where it might be better to consider a commercial option that's more reliable than using your AppSec team's time to deploy something like a cartography or an open source data lake and putting that in a different account and like care and feeding and patching that over time. So again, you always have to be thinking about trade-offs in what you're going to do with your limited team time. So the next one in order of our basic hygiene for DevSecOps is vulnerability management. So pre-production and in production. So I still remember the good old days, when vulnerability management amounted to what you see on the screen here, which is that, we would just run a cron job every night and it would patch the system. And if the system, rebooted and it came back up and it didn't like throw an alert that the service was borked, we knew that system was up to date with all the relevant packages. Of course, things are much more complex today than just like running a yum update, an apt-get update, or a Windows update and patching all the things. So now vulnerability management is an entire discipline, right? Because we have applications that are incredibly complex. The language brings with it third-party dependencies, and now what we call indirect or transitive dependencies. And those, by the way, are the dependencies that other open source dependencies depend on, if that's not a mouthful enough. We're really focused as an industry on like kind of closing the gap there because those things are really easy to identify. There's also vulnerabilities that are introduced by your engineering team. So the people who are writing code that aren't following best practices. Still, we have operating system level vulnerabilities and in OS packages. I'm sure some of you have seen the XC vulnerability that came out last week. In addition to that, because we are dependent on other platforms to run our infrastructure, and we just can't get away from that, is sometimes cloud providers also have vulns. And then the orchestrators, like the Kubernetes, the Mesospheres, the Fargates, the Elastic Container Services, the Google Cloud Runs, the Azure functions. Once in a while, these things will also have patches that either need to be rolled in and applied or forced to apply by the cloud provider. So most of what the industry is focused on right now tends to be around what we call third-party risk, and that is understanding the libraries that we're bringing into these applications and what direct risk and what transitive risk those things bring to our application. And so it's no longer enough just to understand, like, oh, I have Python, I have an old version of the request library, it has this vulnerability. We need to understand, is that vulnerability even reachable or exploitable in the code base that we have? Because we have all this tooling, we have all these categories, we have all this stuff. We're literally swimming in information about how insecure our environments are, and we don't always know how to act on it. So this is where we thought that dependency resolution was going to save the day. And if you haven't heard of SBOMs, SBOM stands for Software Bill of Materials. In fact, we had an executive order in the United States of America that said that all vendors had to create software bills of materials for everything that they provide to the government by September of 2023. So this was supposed to be the recipe book for how the cake was made. And in fact, this was actually relatively effective, this executive order. So between 2021 and 2023, this is the Google Trends chart of how many times folks just Googled SBOM. So we like to see that graph. We made SBOM more popular, but did it actually do anything for us? Generating SBOMs is easy. And remember that EO, all it said is that you have to have the recipe book of how the cake is made. You don't have to act on it if you know that one of the ingredients in that cake happens to be poison. So in order to comply with the EO, all we had to do is warehouse these SBOMs. So we've done that, and now we're actually getting to the point as an industry that we're dealing with them, and we're trying to actually leverage these to be better at vulnerability management. One of the most popular formats for this is SPDX, which is a sort of a JSON format. What you're seeing on screen here is an example of the SPDX for Kubernetes. And one of the things, the first time I ever ran into this, I was like, okay, great. We have this big, long manifest of all this stuff. Like, what the heck do I do with this in order to even know, like, does a vulnerability impact me? And I like free stuff, a former open source developer. One of the things that you can do with it is you can take it to the open source vulnerability database. And Google notably published a great blog in 2022 on just like how hard is it actually to take an SBOM and then use it with the OSV database in order to figure out if something is vulnerable. Turns out, if you have one format, the only thing that you need is probably another format. So we have OSSF now. And so you have to convert SPDX to OSSF to post to a database to see if you have a vuln. This isn't totally awful, and it's not that clunky to just go between two formats, but it's still, it leaves a lot to be desired. So the other thing beyond this is that SBOMs can be quite large. So depending on the size of your application, like let's say you're generating an SBOM for a Docker container, and that Docker container has, it's full-blown Ubuntu or it's full-blown Debian, your SBOM might be larger than a gigabyte. So all of a sudden you're pushing these files around in different formats to different things, and you're getting back this list of findings and then trying to figure out, like, one, does this even impact me? Is it exploitable for my application? You're just drowning in the amount of data that you have available. So this is where kind of the vendor space has kind of stepped up to try to close this gap, right? And that's where we've started to call this thing software composition analysis, where vendors triage all these findings and criticality and attack paths and exploitability so that you don't have to. So everyone that's kind of providing a solution for this has their own methodology and scoring system on top of SBOMs. So it's SBOM informed, like not SBOM driven. It has built-in workflow and prioritization, groups findings to resolve in batch for services that are similar language, etc. So this is one of those other things where you might give strong consideration to not like rolling your own DIY pipeline of stuff unless you just have tons and tons of staff. They're really, really motivated, and they want to just build an open source crazy solution to kind of go through this and find and triage all the things. So the platforms that are doing this, by the way, and are doing it well, are helping engineers prioritize. Because again, people are just buried in data about their environments, right? So we tend to think about this on two axes. We think about it on the severity of the vulnerability, and we think about it over time. So does the system, since the system was running, does it have that vulnerability? If yes, is that vulnerability known to have an exploit that is in the wild today? If yes, then we also increase the severity or criticality. And then, of course, if that service is running in production and we have some telemetry that tells us not only does it have the vulnerability, it has that there's an exploit known to exist and it is being actively attacked, we can consider that the maximum level of severity. Like that needs to wake somebody up. It needs to drop everything off of the plate that somebody has, and they need to actually go and deal with that right away versus just kind of, you know, crawling through this backlog of unpatched things. So the goal, you know, having seen that graph and having seen criticality, is always to stop these things pre-production, right? So we want to arrest them if we can before they go into the environment, but that's not always the case, right? So sometimes they do make it there over time. Sometimes dependencies age in production and they, you know, we become aware that they're vulnerable, or they actually find a way to bypass the tooling that we have. So the next category of thing is continuous scanning, both in code and in cloud. So this is where we get into a little bit of the word salad, which is that we now have these three terms that are becoming increasingly important, which is SAST, DAST, and IAST. Where SAST is the least complex, which is just pattern matching against static code. So like we used to use regexes for this, or regular expressions. This space has evolved greatly, and you'll see an example here in just a second. We have DAST, which is spinning up the application and testing it while it's running. This is notably black box testing, similar to things like fuzzing. And then we have IAST, which is walking through specific use cases. So IAST is great for testing things like authentication flows. However, as we go from SAST to IAST, it requires more and more staff time to actually write the test cases. So for most people, it's very, very practical to just start with SAST. And then once you've kind of derived as much value as you can from that, onboard something like DAST. And then, you know, if you do master that, begin to look at white box testing. So static analysis, or SAST, is probably one of those things that it's not worth your time to DIY. So we used to roll our own. A lot of people were writing different source code parsers, et cetera. And again, this is borrowed from Clint's presentation from 4 years ago, this example here, which is just a regex that's looking for execs inside of blocks of code. But ultimately, this isn't effective because you can have all kinds of different execs and it's not going to always match, right? And so that's where a tool comes in, like SemGrep. And SemGrep is probably one of the best open source tools out there in terms of the rule ecosystem and just, you know, general static analysis. It's built on Python and OCaml, if you know what OCaml is. And it does this really simple pattern matching that will tell you all kinds of things. It can also follow the execution flow of code, or what we call taint analysis now, through a body of software. As a basic practitioner, though, to go back to the question, like, do I have to be a software engineer to like do all this stuff? The answer is no, because as a starting point, you can just take off the shelf a bunch of community rules, and you can immediately start to derive value from a tool like SemGrep. The next thing is DAST, which is dynamic application security testing. We're going to spin it up, and then we're going to run some like blind attacks against it and just see if we're successful. The most popular tool for that, that's probably in the open source ecosystem, is Zap by Simon Bennett. So a lot of folks are using Zap today. I don't think what's overly clear about Zap, though, is that you can actually run Zap inside of a CI pipeline. So if you have things that are really important and interesting to you, you can just run the Zap CLI, and then you can output metrics on relative risks inside of an application using Zap. IAST is still kind of emerging as a thing. So this is like probably one of the gaps that vendors are going to close the most rapidly over the next little while, which is kind of providing tooling around this white box testing workflow, sort of similar to what companies are doing with like synthetics recorders and things. Notably, there is no really great IAST open source software out there. This is a good opportunity if you want to make a name for yourself and you want to go and create some good open source software, so that this slide, hopefully in the future, will not just have tumbleweeds on it. And then the last thing in this category is Cloud Security Posture Management, CSPM, or what we used to just call auditing. It's a really, really important part of just like maintaining your cloud infrastructure over time, is to hunt down misconfigurations in the environment before they're exploited. Great contrived examples are things like public buckets, open security groups, etc. There's kind of two different flavors of CSPMs. One is point and shoot. So a command line tool that you run one time, and it gives you a snapshot in time. The other is continuous scanning with something like AWS Config, or commercial offering like Datadog Cloud Security Management. These are vendor products that you pay for and you spin up, and they just constantly kind of create a data lake out of your stuff. On the open source side, I really like Prowler as a CSPM. And if anybody here was in Deadwood last year, we actually did a really great point and shoot to continuous auditing workshop using Prowler. This is probably the longest lived and best maintained tool in terms of framework coverage. It outputs its findings in JSON and CSVs, so you can make spreadsheets, and then you can triage those. Again, the biggest challenge in all this is like knowing what to act on. And I think Prowler does a pretty good job about putting that. If you want to look at vendor CSPMs, the next generation of CSPMs aren't doing things like only looking at they're not only looking at misconfigs as a single misconfigured resource. They are looking at a combination of things. So instead of just looking at like workload A has unencrypted exposed service B, they're saying workload A has unencrypted exposed service B, which is also accessible via this public load balancer. So they're looking not just at the configuration, but also exploitability, which goes back to that triage theme that we kind of talked about earlier, which is that any good tool that we're going to bring into our DevSecOps strategy needs to take into account the people that are going to be reading and acting on those findings. So the better we can get at kind of assigning criticality based on context, the easier that's going to be for those teams. So we see a lot of pain in this still, right? A lot of companies are trying to implement DevSecOps. They know it's a good strategy. However, consistently they're saying things like, we have more tools than we have ever had in our entire life, and they provide us an overwhelming amount of data that we could not swim through in a year. You know, they generate the equivalent of War and Peace in alerts every day. Triage is a pain. Engineers don't know where to start, and when they do decide where to start, they often don't know how to close out the problem that the tools are surfacing. We have blind spots. engineers don't get metrics from the security tooling. And like going back to that slide about, the phases of DevOps, just because you have DevOps tools doesn't mean that those are exempt from logs, metrics, and monitoring. So for any tool that you bring into your environment, you have to consider the metrics that tool is going to output and how you're going to warehouse those. And then also like silos continue to be a really big thing as you kind of like roll out these cultural strategies. So it's how do you get the teams to come together in the same way that we have been and have been successful in getting purple teams to come together and share that information in this really tight feedback loop. So to go to the technology side of it, which is like the least important part of this, right? Because like technology is almost the easiest thing because we have more technology than we've ever had before to implement this. I remember, when you used to want a continuous integration server, you'd had to like file a PO and like buy a pizza box and install Linux on it. And then you'd have to install Jenkins on it. Now we just have GitHub, right, as the source repository, and GitHub has GitHub Actions. But on the private side, in the AWS Cloud, we have a product that's called Code Pipeline. And Code Pipeline is amazing because it allows you to have blocking and non-blocking stages of build. So if I was to show you a traditional DevSecOps pipeline, you would think it looks like this, right? Like where we send an event to a code pipeline, it runs all these security tests. If any of them fail, we just immediately reject the release and we don't release to production. This is actually not considered to be the best practice, right? The best practice is that we actually run parallel pipelines. And one pipeline is responsible for building and releasing the software, and the other pipeline is responsible for informing the engineering teams about the security posture of the product, because we want these things to be guidance for engineering teams to act on, not a gate to releasing. And ultimately, we want to leave that decision up to the team that owns that service, because part of the DevOps model and the whole empathy conversation is that we're putting those decisions in the hands of engineers. We're just making them informed. It looks like a couple of questions in the chat. I will take questions at the end because we're so close to the end here. Some of the rules of that AppSec pipeline that I just showed on screen is that it has to have really tight feedback loops, right? So we want it to execute at blindingly fast speeds. We don't want it to take 20 or 30 minutes to run every time somebody commits some code. We want it to output messages to the places where people are already working. So that often means Slack or pull request comments or commercial products that facilitate workflow. Again, we're trying not to block the release anytime that we can as a security team, unless it's like a maximum severity kind of a thing. Gates when failure is not an option though. So if we do have things that are maximum risk, like let's say public S3 buckets, and we really just want to block all those, we do block on that. And then emit metrics at every stage to define maturity. So again, depending on the size of your company, the number of things that you develop internally, you have different levels of DevSecOps maturity for each of those. So you have one metrics pipeline, and then you have different bars for where they are in their architecture process. And this is especially important if you're coming into this from a company that already has existing workflows and you're trying to bolt DevSecOps onto that versus kind of doing greenfield. So assign like a low, medium, high level of maturity and then define that and then drive towards that over time. And that is going to, like, how you drive towards that is going to be dictated by your metrics. So here's some examples of good metrics, like number of vulnerabilities by criticality, time to resolve vulnerabilities, ignored vulnerabilities, which is not necessarily bad, by the way. So if we ignore something, that's fine. We just want to know why we ignored it. And was that actually conscious? For example, if you have a vuln in an app and it's not exploitable, like there's no code path to actually get to that vulnerable dependency, we don't care. We can come back to that anytime. Some examples of less good metrics would be things like average age of bugs. So you could have a bug that's years old, and maybe it's in a part of the app that's not super exploitable. So we don't want to like drive down metrics based on the average age of a bug. The oldest vulnerability is still in production. Like maybe, again, it's not that critical or not that exploitable because we're not looking at it in context, or total numbers of findings are really, not great metrics for teams like this to act on. You can also, once you have this, you can add as many tools as you want as desired. So you can add things like Terraform linting and IAM policy reasoning and CloudFormation linters. And you can choose what risk you want to block on as you kind of build up this multi-stage application security pipeline that covers cloud and code. And you can start to have the gates where you want them, the guidance where you want them, and then stand back as like kind of the person behind this operational strategy and then consistently measure over time. And that's going to inform you better and better as you walk through this, how to craft your long-term DevSecOps strategy. So with that, we got like just 4 minutes left, and I will take questions. And I will put this in the chat, by the way, if you like this or you didn't. If you've ever been to a webinar that I have facilitated, I love to give surveys. And the survey just has, kind of some blind feedback on this as well. Opportunity to express if you're interested in a DevSecOps class, or I've been doing these free coffee sessions with people to just like help them with their cloud security and AppSec careers. I'm not selling coaching or anything crazy like that. I'm just sitting with people for 10 to 15 minutes and pointing. The line is quite long, but if you get in the line, I promise I will get back to you.
So Andrew, we do have some questions in the Zoom chat that I'm sure you probably didn't see. I'm not sure if you answered them. You might have answered them live, but as an absolute beginner to join in DevSecOps, should I need DevOps experience? If yes, how long should I be in DevOps?
So I don't think the answer is unequivocally yes or no. There it's going to be just based on how quickly you want to onboard to different things. So I see people come at it different ways all the time. So security engineers that want to be DevSecOps have to generally learn some more code, and people who come from DevOps generally have to learn more security and threat modeling and risk assessment. So it just depends.
Is third party the same thing or similar to middleware?
So middleware is a term that I don't think we use very often anymore, which used to be used to describe pieces of software that sat in between two other pieces of software, like an API, for example, for an Oracle database would have been considered middleware. But really, third party encompasses all that stuff. So anytime somebody else is providing you a body of code that you're inherently trusting, we would just call that third party risk.
When is SAST going to catch up to the AI revolution?
Oh, so I think so SAST, which is the static analysis tool pipelines that we mentioned, there's already a ton of innovation around having AI ML write SAST rules. And I think that's the complementary thing that we're seeing out there.
Are there test scripts or DAST use cases we can use for OWASP ZAP in the pipeline?
Yeah, there are. So ZAP has a ton of really useful scripts for SSRF and SQL injection. Of course, those are not going to be as good as a red teamer that knows how to actually use ZAP and is writing like a custom script that traverses the most important endpoints in your tool. So maybe you can twist some arms on your next like red team exercise and get the red team to give you some of their ZAP configs to run in your pipeline.
What was the name of the tool that you showed in the SAST slide?
Did you want to chime in on the ZAP stuff, Jason?
What I was going to say is we're at the top of the hour, so we're going to do our wrap up. And then if we have any questions, we'll stick around for a few minutes afterwards. So Andrew, if you could sum up everything that you've talked about today in one last final thought, what would it be?
Start with these things before you build out anything that's more complex. So vulnerability management, continuous auditing, inventory, like these are the foundations that you can build the rest of your strategy on. Without that, you're just onboarding products that are going to create more noise. And the more you can consolidate tools and outputs in one place, the more benefit you're going to get.
Yeah. Andrew, thank you so much for sharing your knowledge today with the Antisyphon community. In the future, if you'd like to take a training class with Andrew or any of our instructors, you can always go to antisyphontraining.com and see all the classes that are available on demand and live. We got virtual classes coming up. We have live classes coming up. We have classes coming up. And so we would appreciate you checking that out. In the future, we're here almost every single Wednesday. On Tuesdays, we have office hours. On Thursdays, we have Black Hills Webcast. We like sharing our knowledge. It's the best way to introduce ourselves to you, and it's a great way for you to introduce yourself to others. So please check out any CFPs, that stands for calls for paper, where you can share your knowledge with people in the community. And with that, we're going to end it, but we'll stick around for any questions that we have here for the next couple of minutes. So thank you so much for joining us. If you have to leave, we'll see you next time. And with that, Andrew, great job.
Good job, Andrew. Yes. Well
Thanks
done.
all.
All right. So Megan, any other questions that we missed?
Yes. So hopefully the people are still on. I'm not sure. But let me look. Let me scroll back up. Zoom likes to move stuff around. Sorry.
Getting lots of love, Andrew. So much love. It's a lot of hearts.
Always like these.
Aside from creating an SBOM or SBOM for one's open source software, what do you think? It left. Hold on. Somebody else.
I believe in you.
Where'd it go? Now it's
Did
like
someone answer the question?
No,
Is this
here it
one,
is. Here it is.
SBOMs related to the XZ vulnerability?
What do you think about testing open source software itself, a la the current issues we saw with the backdoor and XZ?
So that the XZ backdoor aside, and I think we've seen a lot of vulnerabilities in open source projects where, you know, the community just hasn't been effective at triaging and merging patches in a timely manner. A lot of open source projects are now onboarding tools like SemGrep. And I know at like the company I work for at Datadog, we actually give really generous grants of our security products to open source projects so they can get kind of those premium tools for free and pass that along to the community.
Somebody said, why does it keep moving? Just to clarify, where do we start in DevSecOps? There is a lot of acronyms, but where does it all start if someone is transitioning to a DevSecOps? What's the what should be the first step?
So yeah, you got to start with DevOps. If you're going to do DevSecOps, again, you can't spell DevSecOps without DevOps. So you have to have those foundations in place, like the automation, the CI/CD, logs, metrics, and monitoring. And then you can start to bolt on security to all those phases. It should be, if it feels like heavy, you're probably not quite ready yet to add security scanners to those phases. So you have to have this culture where you're already kind of familiar with all these things, running through all these automations and providing feedback.
For the parallel pipeline flow, doesn't that open an opportunity to release a high vulnerability that should be blocked from going to production?
It does. So that question is, it comes up really often, right? Which is, you know, should we run these AppSec processes or these scanners as blocking or non-blocking? And I'm not saying never run them as blocking. I'm saying have a darn tight list of things that you are 100% certain that you never want to have happen. Block on that. And then the rest of the stuff, use it as informed. And then leave that up to the people who are accountable, which a big part of DevOps and DevSecOps is identifying the person who is ultimately accountable for that service and letting them make those decisions. And a magic thing happens when you do that, which is that the security guy doesn't have to be the bad guy, because you just kind of leave it up to the service owner to either accept the risk for the business or not.
Yeah. What would you say from IR perspective? The IR team in a way needs to learn all the roles within DevSecOps to be effective?
So I'm going to take this from the lens of security incident response and not like operational incident response, right? So a lot of the foundations of DevSecOps are just going to help your incident response team be more and more effective. And I would say incident response can scale out on top of your DevSecOps strategy, because all those people suddenly now are thinking about how much they care about the logs that they're putting out. like where those logs are going, consolidating them in a single place, tracking changes, which by the way, when you're running everything through automation, it becomes really easy to say who done it because there's no more click ops or human hands going into environments and changing things. So you're starting to make your IR and forensics process simpler and simpler the more you reduce those variables.
This isn't a question, but I wanted to bring it up. Somebody said, I took Securing Cloud Foundations and it was hands down the best training. Thank you, Andrew. So I wanted to make sure that you heard that one.
Love to hear the positive feedback.
Yes. And you put your link for your little feedback thing, didn't you?
Yep, I've got my feedback survey for today.
All right, sweet.
Cute little feedback.
Cute little
survey.
feedback.
You know,
survey.
your little thingy. I like to use technical terms, you guys.
Sure.
Less than 2 minutes it takes to just fill out
Yes.
the feedback form.
I love listening to you ask questions.
Well, I'm sure my face, like I can't even. I'm like
You're just
Oh.
confused. Like you have the question of the question you have is the question. Anyway,
oh.
watching it. There was a question in Discord. I don't know if we got it. Is Synap real or just the new marketing like sim? Promises a lot, but actual results not up to hype.
It was the question about Synapse, the
Yeah.
product.
That thing.
I am
Synapse.
technically
Synapse.
not allowed to answer questions about products in the ecosystem,
Okay.
We're vendor neutral,
Okay.
right?
both as a human being and also as somebody who works for a company that makes a SIM product.
Oh, gotcha. Can
Griffin
you-
InfoSec said that they have a snake oil summit talk about it. So you can check that out.
Thank you, Starbuck. Maybe I do have a hat, but I don't look nearly as cute as Deb does.
Okay, we've talked
Um,
about my hats.
Can you focus on how Sec DevOps apply to things such as pen testing and direct items tied to things such as Linux or Kali Linux, which will be more pertinent to the discussion? I mean, I'm sure we're not going to get into a whole discussion about it, but can you touch on that?
I mean, anybody else here can comment as well, having observed red teams, but I think that planning phase of DevSecOps, building your data dictionaries, having architecture diagrams, all these assets that you can just hand to a red team that you're contracting to come in is going to force multiply that red team's efforts because you're going to spend less time onboarding them. They're going to know all the places to poke at right away, and you're going to get more value out of that engagement.
Okay, well, I think that the other ones have been pretty much been answered. Yeah, it looks like a lot of thanks and they would like the feedback link in Zoom, please.
I can do that.
Okay, we can do that.
Let me, I'll just drop the share real quick and I'll post it.
Ryan's
Ryan's already got it. Ryan did it.
Ryan's on fire, you know.
Yeah.
Did you put it in the resources, Ryan, or did you put it in the chat?
Looks like it's in the chat.
And does that work? Do people see that?
I think that
I think if they're still on Zoom, they should see it.
it
Okay,
does work.
because you've always told me the chat doesn't work, and so I always leave it alone. That's fine.
Who's you?
He,
Ryan?
yeah, he just doesn't want you to use chat.
Huh.
Yeah, it's definitely
Okay.
Do you guys want to talk about the meetup at KernelCon for?
Oh, that's right.
in
Yeah.
Nebraska?
So if anybody's in the Nebraska area, Omaha is
Omaha.
where it is, right?
Omaha.
We're
Omaha.
having a lot of our team is at KernelCon, and they're having a meetup tonight. So we'll post the link for you guys to come and
Mhm.
hang out.
It's also in the resources in Zoom, but I will
Awesome.
pop it here to pop it, plop it, plop it. There it is.
Drop it like it's hot.
Plop it like
Yeah.
it's hot.
And for anyone that was asking earlier, the slides should be in the Anti-cast resources channel as well.
And in the resources here on Zoom.
They're everywhere.
Yes, and it's like all over the place.
Yeah. We try to
We've
get
got
you wherever you're
slides
at.
for days.
Even if you're not in the Nebraska area, KernelCon is a hoot and a half, and
Yeah.
you should go.
Did you go last year?
I did go last year, and I taught
Yeah.
Security in the Cloud at KernelCon. It was a great time. Omaha is a great city.
Okay.
Visit with so
Never
much
been.
fun stuff, and the downtown is so charming.
Oh,
Interesting.
I've never been.
That's
So
not on
maybe
my
next
radar
year
to
we
go
should
visit.
all go and
I'll
It
go.
wasn't on mine. I was so
Yeah.
pleasantly surprised
Mhm.
at how
bet.
cool the
Like,
little
where am
town
I?
was. Yeah.
All right. I think that's it.
yeah. You want to end it like super awkwardly and just all stare at each other and be like, do you have anything? Do you have anything? Do you have anything?
I guess we don't have any more
I
words.
guess, yeah, I could just go home now.
Okay.
On that bombshell, let's ride off into the sunset.
Nice.
So
Uh,
Ryan,
As long as I have my own horse.
See you at Wildwest Hackenfest, everybody.
yeah. And
Come
Ryan,
on down, get you on down there. Wow.
kill it with fire.
Yeah. Thanks all.
All right. Bye.
Thanks, guys.
Bye, Andrew.
Bye.
Thank you.